funky.
Hey guys, welcome back to the channel, and I hope you all are having a good day. I just want to start by saying that I am making about like 6 parts to this review guide because I just feel like the unit has been so long and there are just so many quizzes and stuff. So I try to put a lot of stuff together, and I'm just gonna try my best to go over the topics because I was out of it this whole unit, but I still kind of have like a good grasp on the topics. So I'm gonna try my best to, help other people understand. So yeah, let's just start and learn together. Okay, so basically this question is asking what diffraction is, and basically diffraction is the bending and spreading of light around obstacles or through openings. So basically if a light wave were to be traveling and it came across like, I don't know, a door, something that just stops it in its tracks, is gonna try its best to bend around it, to like go around it, or to like, go through an opening and just like spread and try to go back to how it was initially. So that's basically diffraction. This one is asking what the inner dark region of a shadow is called, and it's the, I don't know how to pronounce it, I'm nervous, the umbra, yes, something like that. And then the inner light region would be your penumbra. I said that so wrong. Let's move on. Okay, so light added to light can produce darkness through what process? That would be destructive interference, and we've learned about this. It's basically like, instead of constructive where the waves build each other and the amplitudes like double or like increase, in this case it's going to cancel each other out because they're on the opposite sides. So one is on the top, the bottom, and then they just make a flat line. In the case of light, it would produce darkness. Number 6. Okay, so the alternating areas of light, so like the little bands and stuff where it's like light and then dark and then light and then dark, those are called fringes. In an interference pattern of light, the light areas are caused by, so yeah, basically what I was saying, constructive, you're gonna get light, so it's gonna produce light, and it would be brighter since it's constructive interference. If it's destructive, it's going to cause dark areas, so like darkness, because they're going to cancel out. Which of the following is correct? When light goes through either a single or both diffraction and interference occurs. So that's just basically something that was in the notes. Diffraction and interference occurs. Also because it's a slit, right? Yes, it's a slit, so that is an opening and it's obstructing the waves, so it's going to go through it. And diffraction and the interference is what happens as a result of those slits, so that's where you see the pattern of the fringes and stuff. It is not equally spaced with a Y. So this is basically just vocab. The answer is single slit. You can read through it, and yeah. Number 10, when the wavelength of a wave decreases, what happens to the fringe? Just something important to know. Your fringe width is going to decrease if the wavelength of your wave decreases. Do I know why that is? No, let's move on. If you decrease the frequency of the light wave used to produce an interference pattern, how would this affect the fringe width? It would increase. So your fringe would, why am I saying fringe? Oh my gosh. So it increases if you decrease the frequency of the light wave. Okay, cool. If you change the color of light used from orange light to blue light. Okay, so let's think about it, because I have to think about this one. So we know the color of the rainbows: red, orange, yellow, green, blue, violet, blah, blah, blah. So Roy something, whatever my teacher said. Is it Roy big? Red, orange, yellow, green. Why am I talking about this? Okay, so we know that orange comes before blue if we're going in order. Okay, so red, orange, yellow, green, blue. So orange, yellow, green, blue. So which means that if we're going from red, which is the longest wavelength, to violet, which is the shortest, your orange is going to have a longer wavelength than your blue. So if you're going from orange to blue, your wavelength is going to decrease. And we know that wavelength decreasing will also affect your fringe width directly, so it would also decrease. Okay. More diffraction occurs as the slit width is decreased. So if you decrease that, then more diffraction is going to happen, and that's just how it works. Because I think the tinier the slit, the more obvious it is, and the more, you know, everything happens. So, decreasing the width of the slit that light goes through result in a fringe that is wider. I wasn't kidding when we said we were learning together. I forgot what fringes meant, so I have to come in from the future. It's basically the bands and stuff, the light and the dark. So basically, if you decrease the width of your slit, then that's going to result in the fringes, like the little bands, like a dark one would be wider and so would be a light one. If the distance between the two slits in the double experiment is increased, your fringe width and spacing would decrease. So if the distance between the slits, you put more distance, then the spacing is going to decrease. So that means they're going to be more farther apart if your spacing decreases. That will confuse me, but just write it down or whatever. If the distance from the slits to the screen is increased, what effect will this have on the fringe width? It will cause the fringes to become wider. If the distance from the slits to the screen. The screen. It's what's showing you the lights, where the bands appear and stuff. So if your distance from that, if you add more distance between it, then it's going to make your fringes wider. Those are just, I don't know. I consider them to be important things. Like, I don't really, like, break my head to understand it. I just kind of write it down and just label it as important. It's just not something that I bother myself about. I just write it down because it's something that's just always going to be that way. You feel me? That's like knowing a relationship between formulas. It's not like you have to know why it works. I mean, come on, it's physics. You just have to know that, like, okay, this is a direct relationship, and I should know that because it's always going to be that way, you know? So please don't beat me up about it. Goodbye. See you in the next part if you're still gonna do that. Bye.